This episode is sponsored by Skillshare.
This is Starbase, Texas, birthplace of the largest and now officially the most powerful rocket ever produced. Over the past 4 years, SpaceX has been rapidly transforming Starbase from what started off as a small backyard operation into a massive, high-tech rocket manufacturing facility and futuristic spaceport. As the size, scope, and complexity of this operation continues to grow with each passing year, there is inevitably a proportional or maybe even an exponential increase in electrical energy demand that accompanies it. This is something that we rarely stop to think about, as most of our attention is constantly drawn towards the next steps in the development of the first and second stage vehicles, the launch system, and the ever-evolving production process. While it's easy for those of us watching from the outside to ignore what's happening below the surface, maintaining a constant and reliable power supply at Starbase has been a top concern for SpaceX since day one. One could even go as far as saying that there were times where they were literally struggling to keep the lights on. Throughout every stage of development at Starbase, SpaceX has been playing Tetris, musical chairs, and Monopoly all at the same time with their power distribution system.
While that is a joke, it is certainly not an exaggeration. I know by now some of you may be thinking that this sounds like a logistical nightmare. Well, you're right. It has been. Luckily, those days are about to come to an end because SpaceX is finally nearing completion on what is arguably the most important infrastructure project since the start of the program. In today's episode, we're going to discuss the incremental steps that SpaceX has taken in order to finesse their way through 4 years of rapid expansion. After that, we will take a look at the new 3-phase power system that will be coming online over the next few months and get an idea of how it will affect daily operations at Starbase going forward. My name is Zach Golden, and welcome to another CSI Starbase Deep Dive Investigation. Hi everyone, thanks for joining us. Before we get started, I want to take a second to tell you all about Skillshare, who is the sponsor of today's investigation. Skillshare is an amazing online community with thousands of inspiring classes for creative individuals who are looking to take their skills to the next level. This is a truly great opportunity for those of you who have something that you're passionate about that you would like to turn into a side hustle or even a full-time career. With Skillshare, you can learn the important skills that you need in order to achieve those goals. There are courses on pretty much anything you can imagine, from graphic design all the way to day trading. I've personally found this platform to be extremely helpful, as I'm constantly working to increase the quality of production with these episodes. As an amateur content creator, sometimes it's difficult to figure out the best way to present these highly detailed reports in the most effective way possible. I recently completed this course on scripting, shooting, and editing YouTube videos by Marquez Brownlee, which opened my eyes to a lot of techniques that I hadn't previously considered. Being able to see the way he goes through his creative workflows almost made me want to rewrite this entire script for this episode. This is an awesome resource that I highly recommend trying out for yourself. And now, the first 1,000 people to use the link in the description will get a 1-month free trial of Skillshare. On September 22nd of 2014, SpaceX officially broke ground on their privately owned spaceport, now known as Starbase. SpaceX chose this location after considering multiple other options in Alaska, California, Florida, Georgia, Puerto Rico, and Virginia. The decision to make Boca Chica Village the home of the future Starship program was one that is still surrounded by a significant level of controversy, even to this day. But there were several factors that made South Texas one of the most ideal places for SpaceX to set up shop. One of the benefits of this location is its proximity to the equator. The closer you are to the equator, the more you can take advantage of the Earth's rotational speed to give you a boost on the way up. Being in a coastal location is also ideal because it provides a large expanse of unpopulated or sparsely populated land and water, which minimizes the risk to human life and property in the case of launch failures or accidents. Unfortunately, the same isolation that makes this an ideal location to construct a commercial spaceport also creates a few important logistical hurdles. One of the biggest issues with building this in such a remote location is the limited access to reliable power. When I say limited, what I really mean is that ever since the day SpaceX broke ground in 2014, Starbase has essentially been an off-the-grid operation. This wasn't to say that there was zero power being delivered to the area, but the system that was available at the time was never suitable for even the most basic of SpaceX's needs. I want to quickly explain a concept that is going to be repeated often throughout this investigation. Since we are going to be discussing power distribution systems, we need to understand the difference between single and three-phase power.
In a single-phase power system, there are two conductors. One of them is considered the live or hot wire, while the other is the neutral wire. In three-phase systems, there are either 3 or 4 conductors. This includes 3 hot wires and 1 neutral wire. In areas where the energy demands are greater, you may see multiple parallel feeds running on the same utility pole. Typically, each of the 3 phases will be color-coded with black, red, and blue wire. White is used for the neutral conductor. If the supplied voltage is greater than 480 volts, then brown, orange, and yellow wires will be used instead. This color coding is standard for applications in the United States. In AC power systems, voltage is supplied in alternating peaks of positive and negatively charged energy, which forms an oscillating sine wave if we were to observe it using an oscilloscope. This is repeated 60 times every second. As shown in this footage from the Engineering Mindset channel, you can actually observe this in your home if you were to record your light bulbs using a high-speed camera. In a 3-phase system, there are 3 alternating waveforms instead of 1, and they are offset from each other by 1/3 of a cycle. The result is a more constant and balanced power supply. The other benefit is that the power is evenly distributed across each of the 3 conductors, which allows them to transmit 3 times as much power as a single-phase system. In industrial settings, 3-phase power is commonly used in data centers and manufacturing facilities, which typically have a high power demand requirement. It is also ideal for operating large electric motors because it provides much smoother operation. 3-phase motors also have a higher torque output in comparison to a single-phase motor. If you want to learn more about how that works, I put a link to this video from the Engineering Mindset channel in the description. Single-phase power can typically be found in residential areas near small businesses like retail stores, restaurants, and offices. You will also find it near smaller commercial buildings and also in rural and remote areas.
The reason for this is because single-phase power systems are significantly less expensive to install and maintain. Also, the power demand requirements are usually far lower in those settings.
With that explanation out of the way, this video from Starship Gazer taken on April 28th of 2021 shows the pre-SpaceX power transmission lines from Brownsville to Boca Chica Village. Now we know how to identify this as a single-phase power line by observing the 2 conductors on each utility pole. The wire on top of the utility pole is the hot wire, while the lower one is either neutral or for communication. This transmission line travels 12.5 miles, or 20 kilometers up Highway 4, and along the way it supplies power to all of the homes you will pass on the way to Starbase. This also includes the Rocket Ranch property. By the way, if you ever visit the area and want to camp somewhere near Starbase, this is the place to go. After this above-ground power line reaches Richardson Avenue, it transfers underground for the remainder of the way. For those who don't know this area that well, Richardson Ave is where the Lab Padre Raptor Roost, Rocket Ranch, and Starship Station launch viewing areas are located. If you saw my footage from the first integrated flight test, this is about where that was filmed from. Once you finally reach the beginning of Starbase, near what is known as the Sanchez site, you'll begin to notice junction boxes or access hatches that are stationed about 200 meters apart from each other, all along the south side of Highway 4. Each of these terminals allow for smaller power lines to branch off from the main line and send power across the street to where it's needed. We believe that one of those locations, which is possibly the only one that's actually inside of the production site, was the UT RGV Stargate building. This was finished in 2018 and was originally designed to be a 15,000 square foot facility used for research and collaboration on a variety of projects. Once this single-phase line reaches LBJ Boulevard, it turns into the village and supplies all of the homes located in the Boca Chica neighborhood. From what we were able to gather, this 50-year-old transmission line was not very reliable and would often have periodic outages for various reasons. One of those reasons is because of the regular flooding in the area that occurs during storms. As you can imagine, this is extremely inconvenient for residents and employees living in the village. But for the actual Starbase facility, it didn't really matter because this low-voltage single-phase power was not ideal for operating all of the heavy machinery and equipment that would eventually be needed at the build site and launch complex in the coming years. With this being said, it was extremely important for SpaceX to produce their own energy in order to get this operation up and running. So sometime in 2018, they installed a 5.4-acre solar farm, which could supply 1 megawatt of power. This was located near the tracking station, which was added around the same time. The solar farm originally featured 11 Tesla power packs and one of the original Megapack modules, which could be used to store energy generated by the solar farm.
The total capacity was about 4.8 megawatt hours of energy storage. A megawatt hour is a unit of measure which is commonly used to measure the amount of electricity consumed or generated over a specific period. When combined, these battery packs can output 4.8 megawatts for up to 1 hour before the power bank is depleted. So if you have a production facility that's pulling 1 megawatt, then you would have 4.8 hours of backup power with this setup. This was a relatively cheap solution that gave SpaceX the ability to generate their own clean energy on site.
Most importantly is the access to three-phase power. The solar panels output DC power, which is fed to the Tesla batteries. From there, an inverter is used to convert the output into three-phase AC power. This could now be used to supply both the build site and also the launch site, which was only in the beginning stages of land development at this time. There are electrical boxes for the solar-powered three-phase system all along Route 4 between the tracking station and the launch site. This is what the short rectangular junction boxes look like on the inside. You can see that there are 3 separate panels, one for each phase. These are also known as bus bars. Each bus has 4 terminals on them, which allow for multiple parallel feeds of three-phase power lines. The final junction box is located just across the street from the suborbital tank farm at the D1 entrance. By the time this image was taken on June 23rd of 2020, this three-phase transmission line was actually not live yet at the launch site, even though testing operations were well underway at this point. The reason for this is because there was a key component missing that would be needed in order for it to be used. And that was the control bunker that would later be located on this rectangular pad. At this point, the suborbital tank farm was controlled using these mobile trailers, which required several generators in order to power the systems and equipment needed to operate Test Stand A. While they were waiting on the completion of the structure, SpaceX also began running underground conduit lines for the three-phase power system, which would later be used to power the launch pad and propellant storage farm. This line runs in front of the D2 entrance, in front of what would later be the 8 vertical storage tanks, and then into the comms building, which controls everything inside of the tank farm. From there, it runs into the fluids bunker, back across the front side of the tank farm, and there is another line that runs to the base of the launch mount, and one more that goes to the base of the integration tower. This forms a pretty large network of electrical conduit at the launch complex, but we will return back here in a bit because there is more to discuss first. Back over at the suborbital tank farm, we can see that once the controls bunker was completed, SpaceX was able to transition away from the trailer-mounted control systems. By the end of April 2021, the suborbital tank farm was fully tied into the solar-powered three-phase system. As the Starbase site continued to grow, their power demands increased as well. One of the biggest consumers of energy at this point would have been the 3 fabrication tents. The reason for this is because SpaceX was beginning to transition into using welding robots for various functions. This includes joining stainless steel rings together as they are creating 3- and 4-ring tank sections. They are also used for welding domes to the tank walls once they've been sleeved, and for attaching the tens of thousands of pins that are used to connect the thermal protection system tiles on the outer skin of the vehicle. This provides a huge increase in construction quality of the vehicles now that they're no longer hand welding all of their ring sections. In June of 2020, SpaceX broke ground on the Highbay, and the main construction was completed 4 months later in October. 5 months after it was finished in March of 2021, the first of several massive bridge cranes that would later be used at Starbase was installed right here inside of the same Highbay where our headquarters is based out of. As you can imagine, a crane like this with a 180-ton lifting capacity is going to require a lot of power in order to run it. In December of 2021, SpaceX began commissioning of all the different systems related to Stage 0. While there is some pretty heavy-duty machinery involved with the integration tower and orbital launch mount, most of these systems are rarely being operated simultaneously. With that in mind, the drawworks winch that controls the vertical motion of the chopsticks has a large power draw, potentially up to 4.5 megawatts if it's being maxed out. But the system that requires the greatest amount of power, and also for the longest duration, would be the orbital tank farm during propellant loading. These are some truly massive pumps, and they have an equally large job, as they are responsible for transferring thousands of tons of cryogenic liquid propellants to the ship and booster. Looking at this label on the side of one of the methane pumps, we can see that it's rated for a maximum of 555 kilowatts. These are a bit smaller than the liquid oxygen pumps, which are probably pulling somewhere around 1,500 kilowatts each. Of course, that is their maximum rating, and based on the other specs here, the actual power draw may be significantly less than that. When SpaceX first began operating the orbital tank farm, they were only using 2 out of the 5 available liquid oxygen pumps, and they used 2 out of 4 methane pumps. There's no way to know for sure, but it's possible that the amount of pumps SpaceX is choosing to operate could be directly correlated to the amount of power they're able to supply to them. They later added 1 additional pump to either side, which increased the rate that they can load propellants onto the ship and booster. but it also increased the power draw by 50%. Returning to the production site, in August of 2021, SpaceX broke ground on the first megabay structure at the production site. This building received not one, but two 150-ton bridge cranes, which became active 9 months later in May of 2022. It also has a few massive turntables and robotic welding stations. These were also added to the Highbay as well by this point. In September of 2022, SpaceX completed the first phase of the Star Factory after 6 months of construction. This is basically the smaller equivalent of a Tesla Gigafactory, except for Starship. The Phase 1 section of the Star Factory has 4 bridge cranes inside of it, which are probably already starting to rack up a pretty decent amount of operational hours by this point. Not only this, but SpaceX has drastically increased the amount of welding robots used in the early stages of production ever since this building came online. We believe there are 15 to 20 workstations in this building, and it's safe to assume that every one of them has at least one, if not more, welding robots, and a cantilever jib crane for lifting smaller items into the ring sections. And if all of this wasn't enough, SpaceX is now in the process of constructing a second megabay. At the same time, they are expanding the Star Factory to cover a much larger area than what was originally portrayed in their conceptual renders. The final version of the Star Factory will not only replace the 3 fabrication tents, but it will also take up all of this area shown here. In the end, it will be roughly 6 times larger than its current footprint, if not more. By now, SpaceX has already completed most of the demolition work on the propulsions building, windbreak, and ground fabrication building that needed to be removed so they can continue the next phase of expansion. So once all these major structures are finished, we are talking about 2 additional 150-ton bridge cranes, plus up to 20 smaller bridge cranes for the Star Factory, 100 pedestal cranes, and a very large number of welding robots. Those may actually be the largest consumers of power if I had to guess, but next to that could be the HVAC systems used to maintain climate control in all of these large manufacturing spaces.
There is a lot more here that I'm not even mentioning, but I think you probably get the point. Starbase is officially transitioning into a legit industrial rocket manufacturing facility and commercial spaceport. So the question of the day that we are here to answer is, what is SpaceX doing in order to keep up with the drastic increase in power consumption that has and will continue to result from all of this expansion? Well, the answer to that is a 2-part solution. There is a long-term permanent solution, and there is a multi-layered temporary one that SpaceX has been using for years to get them through up to this point.
The first layer of the temporary solution is pretty basic and relatively easy to implement, but it has some limitations. In 2021, SpaceX increased their amount of solar energy capacity when they added 1,855 panels along the container wall near the ground fabrication building and the entire length of the Sanchez site. More solar production capacity meant that they could also increase the amount of battery storage as well. So on June 26th of 2022, they added 2 additional megapacks to the tracking station. This gave them an additional 5.2 megawatt hours of storage, bringing the total up to 10 megawatt hours. The problem with solar power is that even if the entire 100,000 square foot roof of the Star Factory is covered in solar panels, that would only give them an additional 0.4 megawatts of power. So due to surface area limitations at Starbase, I don't think solar power can ever be the primary source of energy in the long-term solution.
With that said, let's discuss the second method for quickly getting more power where you need it. Well, as I'm sure a lot of you can probably guess, there really aren't any other options out there other than bringing in more generators. This has been the solution of choice for almost every operation you can think of up to this point at Starbase.
1 megawatt of power coming from the solar farm was not enough for SpaceX to conduct vehicle testing at the launch complex without causing disruptions to the manufacturing process. So in order to adequately supply the orbital pad, there was a 2 megawatt generator attached to the controls bunker. This seemed to be enough to get SpaceX through the first year of ground testing. That was the time period I would consider as the initial proof of concept phase for stage 0. SpaceX was carefully dialing in the various mechanical systems and their operational procedures as they progressed through the early stages of booster and full stack testing.
But was this lone generator enough power to allow them to simultaneously load 5,000 tons of propellant into the first and second stage vehicles in 90 minutes flat? I don't think so.
In October of last year, shortly before SpaceX began jumping into static fire tests with higher engine counts and full stack testing with Booster 7 and Ship 24, 4 additional diesel generators were delivered to the orbital tank farm. That brings the total up to 10 megawatts of power. SpaceX also brought back 2 of the generators that were previously providing power to the suborbital tank farm. Based on these observations, I believe that the solar farm was likely providing little or no power to the launch complex from that point on. There are also smaller generators scattered all over the place throughout the production site. There is one for the grounds fabrication building, propulsions building, several outside of the fabrications tent, one for the Highbay, and another for the Megabay. Even the Star Factory currently has 2 generators sitting outside of it, which could be providing up to 3 megawatts to the building. We aren't certain of their capacity, but it definitely exceeds what is able to be provided by the solar farm.
Now, initially I thought that these generators were only being used for backup purposes. It makes sense that this would be needed, especially during the night or on days where the solar panels are struggling to meet the demands due to heavy fog and long periods of rainstorms or overcast skies. But as I was looking through years of images, I noticed a trend with the movement of all of these generators that began to tell a pretty interesting story.
We can see this best when we look at the fabrication tents. There is a large branch from the solar-powered distribution line that runs straight through the first 3 tents. It ends outside of where the 4th one used to be located. This may be temporarily in use at the Star Factory as well. For verification of this, we can look at footage from the Everyday Astronauts tour of Starbase back in the summer of 2021. In Tent 3, you can see one of the distribution panels, or breaker boxes, along the side of the wall in the position where we are expecting it to be. These lines run under the concrete and are covered with removable steel plates for easy access. You can see these between each of the tents. If you scan through months of RGV aerial images, you will notice that a portion of the generators surrounding these tents are often located near the underground culvert, which gives them access to provide backup power to the facility. The other thing that we noticed is that during the hotter months of the year, these generators could also be found near the AC units on the outside of the tents. From what we can tell, the primary source of ventilation are the large box fans on the walls of the tent. As you can imagine, a simple fan like this, which probably doesn't put much of a load on the solar power grid, is not going to be enough to actually cool the tents once the temperature outside exceeds a certain level. They're really just designed to cycle fresh air. So on those hotter days, it will actually be necessary to run the AC units located on the outside of the tents. Unlike the wall-mounted fans, these will definitely put a significant load on the grid during peak hours of the day as they try to keep the combined space of nearly 300,000 square feet cool enough to work inside of.
For this reason, it appears that SpaceX made the decision to completely isolate nearly every air conditioning unit on site from this solar-powered grid, and instead run them off of generators. Some of these tents appear to have a far greater amount of waste heat being produced on the inside than others. For example, this tent, which is the smallest of the 4, is where all the hydraulic presses and heavy metal forming machines used to be located. In this image taken in August of 2021, you can see 7 generators outside of the tent, with most of them being located near an AC unit. While this does seem to have been enough to satisfy the basic needs in order to operate this manufacturing facility, it certainly creates a lot of logistical issues. For one, all of this equipment requires a considerable amount of maintenance. Luckily for SpaceX, they have had a United Rentals repair shop on site for much of the last 2 years. The other issue is that all of these generators are likely running off of diesel fuel. Each of them will have to be refilled at least once a day, if not more. When you combine that with the fuel needs of all the mobile cranes, service vehicles, aerial work platforms, and SPMTs that are moving around site all day long, it can become pretty difficult to keep up with. Anyone who's ever worked on a large job site can probably tell you that it's not uncommon for the fuel truck guys to be on everyone's shit list after forgetting a piece of equipment and letting it run dry. Beyond that, the entire purpose of a generator is to be used for backup purposes, not for primary energy. When you factor in the cost of rental, maintenance, and fuel, this may actually be one of the most expensive and inefficient ways that you could possibly run an HVAC system long term. But for years, there was really no other option. All right, before we get into the permanent solution, we have to discuss another large power supply source located near this building because it may have some relevance to the overall energy balance equation going on out here at Starbase.
In January of 2021, as the Highbay was nearing completion, SpaceX broke ground on a rather large 2-phase industrial construction project, which would allow them to produce their own cryogenic liquid propellants on site at Starbase. As you might be able to imagine, the ability to produce or process their own propellants is highly desirable when you're working with a vehicle of this size, especially if you have plans of launching it 5 or 10 times a year. There is a lot of ground testing that occurs before launch that consumes a considerable amount of these propellants as well. To put this into perspective for you, in order to fill up the orbital tank farm, and we aren't even going to consider the suborbital pad or the new cryo testing facility down the road at the Massey site. Just to fully top off the orbital tank farm requires 269 loads of methane, 393 loads of liquid oxygen, and 263 loads of liquid nitrogen according to our estimations. I admit that we aren't 100% certain of where the fill station for these tankers is located, and they very well could be sourcing from a location closer than what we are assuming here. But with that said, we are pretty confident that most of these deliveries are coming from either Houston or Port Arthur.
So, at a minimum, this is a 12-hour, 800-mile round trip. That's nearly 1,300 kilometers for those of you who demand metric units. Now, let's multiply that by 3,692, which is the number of liquid oxygen and liquid nitrogen tankers that we have seen offloaded at Starbase since the CSI field agents began keeping track just over a year ago. Once you do this, you end up with a total distance of about 2.6 million transportation miles over a 12-month span. Yeah, a number that large is kind of hard to wrap your mind around no matter what units you're using. So instead, we can equate this to circumnavigating the entire planet 104 times. Yikes, I know, right? That is extremely inefficient, and also a highly undesirable way of doing things. But if they could instead produce these commodities themselves, literally 2 miles away from where it's needed, that number falls to 6,488 miles. This also reduces transportation costs from an estimated $1.5 million down to about $4,000. That's like Elon's pocket change. So in order to reduce their environmental footprint, SpaceX constructed this air separation unit at the Sanchez site.
This is actually a used facility that was previously located somewhere in Louisiana, although I'm unsure of its exact origin. An air separation unit, or ASU for short, is a cryogenic distillation plant which is used to separate air into its primary components. These three components are 78% nitrogen, 21% oxygen, and about 1% argon. I'm not going to go into how this works today, but I will post a few links in the description if you would like to learn more about it. Once the process is complete, the liquid nitrogen is stored in the two large horizontal tanks. The mid-sized tank is for liquid oxygen, and then finally the argon is stored in the smallest of the four tanks next to the fill station. The argon produced in this process can be used for welding operations at the production site. The important thing to note is that this is a rather energy-intensive process due to the various stages of purification, compression, cooling, and distillation that are used to separate the air into these individual components. So, in order to power this ASU, SpaceX purchased a used power plant facility from a timber processing plant in Oregon. The main components of this facility include 5 natural gas generators, which showed up on June 8th of 2021. Each of these generators are capable of outputting roughly 2.9 megawatts of power. In total, they provide 14.6 megawatts of energy. Situated nearby is a large bank of radiators, which is essentially the cooling system for the 5 generators. This power plant was assembled inside of the Sanchez site, adjacent to the air separation facility. I was able to confirm that the electrical output coming from these generators is connected to the air separation facility through underground conduit paths that I was able to find. After the natural gas power plant and ASU finally came online, we expected to see SpaceX transition into producing their own liquid oxygen and nitrogen. This would have been rather obvious once the tanker trucks began making frequent trips between the Sanchez site and the orbital launch complex. In the year and a half since the facilities were commissioned, we have occasionally witnessed cryotankers filling up from the ASU, but it's pretty rare to actually catch this occurring. From what we could tell, most of these commodities were still being sourced from third-party suppliers. We were able to verify this after the aborted launch attempt on the 17th of April this year. It took 3 days to replenish the tank farm. During that time, most of the liquid nitrogen and liquid oxygen tankers we observed approaching and leaving Starbase were seen traveling up and down Highway 4. However, as I was recording this footage, I did manage to catch at least 3 tankers make the turn into the Sanchez site to resupply from the ASU. For confirmation, we can see that there was venting occurring near the facility after the first tanker showed up. Now, these aren't exact numbers, but I would estimate that less than 10% of the tankers were filling from the Starbase ASU, while the others were stuck making the trip all the way to Houston. This is a quick way to lose friends if you happen to be one of the lucky ones. Anyways, this raises a few questions. If SpaceX has the ability to produce their own liquid nitrogen and oxygen, then why haven't they fully shifted over to self-supplying these commodities? I think the answer to this question is that the ASU has been operating at a reduced capacity level since day one. It's possible that the power plant is currently acting as a backup power supply for the solar farm. In other words, SpaceX could be diverting energy away from ASU production in order to keep up with the power demand at the production site. As I was performing research for this investigation, I wasn't able to find much proof that this is actually occurring, other than the presence of this rectangular box right here. This is similar to the other 3-phase junction boxes that we identified earlier, but I'm not sure if it's enough to confirm this theory. Another possibility is that it might just be economically unfeasible for them to operate this power plant at maximum capacity for extended periods. Most power plants like this are fueled via a pipeline, which is capable of supplying a constant flow of natural gas. Unfortunately, there is no natural gas pipeline from Brownsville to Starbase. Instead, SpaceX supplies fuel to the power plant via LNG cryotankers. The cryogenic liquid is vaporized in this distribution trailer before it is supplied in gaseous form to the generators.
In my opinion, because of the 800-mile round trip to refill LNG tankers, this is a pretty inefficient power source. A configuration like this leads me to yet again assume that this power plant might be intended for backup purposes only and not as a primary supply of power. Now, I'm sure some of you are probably aware that there is a gas well located on this property, which is actually how the Sanchez site gets its name. But based on publicly available GIS data, it was never a viable option for use as a continuous source of fuel. The last reported production from this well was back in 2014. Even before it was abandoned due to low production volumes, it would not have been able to supply enough gas to run this power plant. For this reason, I'm not giving the gas well any further consideration here. But why would SpaceX install a distillation plant like this if they didn't have a continuous supply of energy needed to run it? Well, keep in mind that this is speculation, but I think the answer to this is the same solution that will solve the rest of SpaceX's power demand issues at the production site and launch complex. On that note, now that we have this background information out of the way, let's discuss the major development that will reshape the way SpaceX conducts operations here at Starbase. As I said in the beginning of the episode, this is one of the longest ongoing projects at Starbase and has been in the works for nearly 2.5 years.
The first sign that this much-needed infrastructure project was about to commence was several sets of electrical conduit being laid inside of 2 trenches at the Sanchez site. This conduit path ran through the middle of the property down to the shipping container wall, which was in the process of being assembled. Over the next year, additional conduit paths would be routed to various locations within the Sanchez site. From what I was able to unearth during my investigation, this is the layout of the conduit that was distributed throughout the site. It's important to note that this is just a pathway for the actual power cables to be pulled through later. That part of the job wouldn't commence for at least another 2 years. Once the conduit runs are completed, they are encased in concrete, which is painted red to make them easily identifiable in the future if any additional groundwork needs to be performed. Meanwhile, along Highway 4, the local power company, known as the Magic Valley Electric Co-op, began installing new utility poles alongside the existing single-phase transmission lines. I tried to nail down a date when this started, but was unsuccessful as there was never any official announcement of it. In the unknown number of months it took to complete this, SpaceX laid down the new underground conduit for Phase 1 of the Star Factory. There was a huge concrete vault, which appears to be the transformer station for the entire Star Factory. It will probably run from this location all the way to what you might consider the front of the building near Highway 4. The split conduit paths leading out of this vault made it pretty obvious that SpaceX was eventually planning to expand the Star Factory in this direction long before it became public knowledge. From there, it wraps around the perimeter of the future Phase 2 section of the Star Factory and then turns down towards the highway for a few hundred meters. After this, it turns one final time towards the solar farm and tracking station. By the end of August of 2022, they completed the path all the way to the payload integration facility where the Starlink satellites are stored. Returning back to Highway 4, by February of 2022, Magic Valley had wrapped up installation work of the 17 miles of utility poles starting all the way back from the substation, and the 3-phase power lines were also finished as well. You can see that below the 2 sets of parallel 3-phase conductors, there is also a single-phase line which we believe will continue to service the homes along Highway 4 and will hopefully provide more reliable power for them. Just like the old single-phase line, once the transmission line reaches Richardson Avenue, they went underground for the remainder of the way. Over a period of about 3 months, construction crews ran long spools of conduit tubing up the remaining section of Highway 4 alongside the old single-phase lines. This continues until just past the Sanchez site before it stops at the corner of Remedios across from the Stargate building. There are underground access vaults in these 3 locations.
We haven't seen any evidence that the transmission lines have been pulled through this conduit yet as of today. But it's important to mention that this marks the end of Magic Valley's portion of the job. Everything after this point is up to SpaceX. That should include the line that will eventually need to cross the highway and enter into the Sanchez site, which I don't think exists yet unless they used horizontal directional drilling to get it there.
Starting in December of 2022 and continuing over the next 4 months, SpaceX began stockpiling huge piles of cable near the tracking station in preparation for the final steps. In total, there were about 60 spools of 500 kc mil cable delivered to Starbase. I wish I could tell you how many miles of cable that is, but maybe someone in the comments section would know. Needless to say, it's a lot. At the end of March, SpaceX began running the final main lines of conduit for the build site. This included lines that should supply the Highbay and Megabay 1. There is a pathway that leads towards the Sanchez site, but it ends in the corner of what used to be the Airstream Park. This is a pretty odd location for it to end, so I think there will eventually be a line connecting this to the vaults on the far side of the rocket garden. I haven't found any proof that this exists yet, which is why I think it's unlikely that the natural gas power plant has been providing power to the rest of the site. The very same week, 25 months after the first conduit was laid, SpaceX finally began pulling the first cables at the Sanchez site. At the beginning of May, SpaceX laid the final conduit between Megabay 1 and the Star Factory, once the foundation for Megabay 2 was completed. I believe this officially joins every section of the entire production site area. As of right now, SpaceX is still in the early stages of pulling through all of this wiring. They will also need to install the low voltage transformers and whatever additional equipment that will be needed for the individual facilities.
But before this system can go live, there's still one more major component that will be required. For the sake of time, I'm not going to go too deep into the mechanics of this, but from what we were able to determine, the transmission line coming in from Brownsville should be a 32 kV feed. The 500 kc mil cable being pulled throughout the site is only rated for 15 kV and will likely be operated at a lower voltage of around 11 kV. So before the incoming feed can be distributed through the Starbase electrical grid, the voltage will have to be reduced down to a usable level. This is accomplished through the use of transformers inside of an electrical substation. As I mentioned earlier, Magic Valley's portion of the job ended with the transmission lines, so SpaceX will need their own substation in order to distribute power throughout the site.
There is an electrical substation currently under construction located in front of the natural gas power plant. SpaceX has completed the maze of electrical conduit that will run under the substation, but among other items, it's currently missing a very large transformer that should be showing up any day now. It should look similar to this one between the natural gas power plant and the ASU, except much bigger. It's hard to grasp the size of this from the aerial view, so here's an image taken from the ground as it was being delivered to Starbase. Now that we know where the power distribution hub is located, let's turn our attention to the launch complex. As we learned in the first half of this investigation, SpaceX finished laying out all of the main conduit lines for the orbital pad nearly a year and a half ago, so the only remaining thing to do here is to connect it to the new substation. If you have tuned in to the RGV Starbase weekly live streams over the last month, then you are probably aware that SpaceX has already begun this process. In the middle of May, SpaceX began digging 2 parallel trenches on the side of Highway 4 between the launch complex and the tracking station. As of the time of this episode, they are currently working in the opposite direction and are in the process of continuing these trenches all the way to the Sanchez site. This portion of the upgrade seems to be progressing faster than any other area on site, because there isn't much conduit involved. Instead, they have chosen to go the direct burial route with the large spools of cable. Each of these trenches have a parallel set of 3-phase conductors laid inside of them. There's also a single line of conduit piping, but we believe this is for data and comms. Unlike the production site, we know exactly how many parallel feeds are on the ground here and can actually estimate how much power is being delivered to the launch site. Based on the specs of 500 kcml cable, which is rated for 500 amps and likely being operated at 11,000 volts, we should expect to see a maximum capacity of about 16 megawatts for each of the 6 cable 3-phase feeds being run. That's the equivalent of 8 of these 2 megawatt diesel generators. Since they are running 2 separate feeds with 6 cables per feed, the total will be about 32 megawatts of power. This should be more than enough to satisfy all of their future needs. So if they decided to build a second launch tower in the future, theoretically they could be able to perform testing operations on both orbital pads at the same time. But honestly, I believe that if they were actually preparing for a second launch pad, there might actually be 3 separate feeds here instead of 2. One of the first things I would expect SpaceX to do with all of this extra power at their disposal would be to install the remaining liquid oxygen and methane pumps. This would allow them to bring propellant loading down to 45 minutes, which I believe Elon has stated is something they would like to do in the future. Of course, they will need additional heat exchangers as well, but they already have at least 2 of them ready to go. As of the time of this episode, SpaceX has already removed 5 of the trailer-mounted 2 megawatt generators, which might be a sign that they are expecting all of this work will be completed before the orbital launch pad is operational again. In my opinion, it would probably be smart to leave at least 1 generator here in the event that they lose power in the middle of propellant loading. But there may be another solution for this in the works as well. As of the last week of May, we have seen 3 rectangular boxes that have shown up to the Sanchez site. These are located right next to the electrical substation. You can see that there is room for 3 more of these boxes, and even though we can't see what's under the tarps, it's pretty obvious what these are. As you have hopefully guessed, these are additional Tesla Megapacks similar to the 3 located near the tracking station. The only difference is that these should be the newer version of the Megapack, which should have a slightly larger capacity. These should be 2.9 megawatt hours instead of 2.6. So in total, there would be 17.4 megawatt hours of backup power from these batteries. When all is said and done, I think we might expect to see nearly every other generator on site, other than the natural gas power plant, to disappear. They should no longer be necessary, even for backup purposes. The solar three-phase system will no longer be the primary source of energy and will instead be used to provide backup power when needed. It will also help stabilize the power grid if necessary and allow SpaceX to reduce their energy costs during peak usage hours.
This is a big step towards improving the efficiency of operations at Starbase. Another change that we should be on the lookout for over the next year is for SpaceX to drastically increase the amount of liquid oxygen and nitrogen that they are producing on site. Over the last 6 months, we have seen additional equipment for the ASU arrive at Starbase, which is a sign that they are preparing to expand its production capacity in the near future. Revisiting the two theories from earlier in the episode, if the natural gas power plant is currently providing backup power to the production site, then it should soon be free to commit 100% of its output to the distillation plant. The second, and in my opinion more likely option, is that SpaceX is actually intending to run the ASU off the three-phase system as well. I think it would be more efficient than using the power plant for that purpose, especially since there is currently no natural gas pipeline to provide a continuous supply of fuel. Instead, they can reserve it for use during peak hours when they want to relieve some of the load from the Magic Valley power grid. As I said, this is a ton of speculation here, so we're going to have to follow up on the situation as it continues to develop. In the meantime, I hope you all enjoyed this deep dive investigation. If you're new to the channel and made it this far into the episode, then don't forget to hit that subscribe button as well. I know this isn't the typical kind of topic most people are expecting when searching for updates about Starbase, but it was exciting to me, so I figured I would share it with all of you. If you would like to support the CSI Starbase YouTube channel so we can continue to bring you episodes like this, then please consider becoming a channel member or monthly supporter on Patreon. I want to thank everyone who has supported us so far, and give a huge shout out to the 169 individuals who donated towards the GoFundMe I posted on Twitter a few weeks ago, after my production laptop assassinated itself. I'm not gonna lie, that was a pretty massive setback, but thanks to all of you, I was able to get back up and running quickly with only a small amount of downtime. I know it's been like a full month since the last episode, but this one was way more difficult than I expected. And on that note, shout out to the team of CSI agents who helped me gather all this information. Before we go, I want to thank all the photographers whose content was used in today's investigation for all of their hard work documenting history over the last 4 years at Starbase. And last but not least, thank you to Skillshare for sponsoring today's episode. Don't forget to check out that link in the description. Hopefully I'll see all of you on the next deep dive investigation. For now, this is Stage Zero Zach, signing off.